Okay, hi guys, so we'll be continuing on seeing more concepts on titration from the previous lecture. So we discussed in the previous lecture that n1 v1 equals to n2 v2, where um, the left hand side is the number of equivalents of A and the right hand side is the number of equivalents of B. Okay, so this is the number of equivalents of A and this is the number of equivalents of B. And suppose if you have to write, so in this case the volume was in liter, but suppose if you have to write the number of milli equivalents of A, then we should be equating it to number of milli equivalents of B. So in this case n1v1 should be equal to n2v2 and the volume in both the cases would be in liter. Okay, so as we all know that since normality is equals to molarity into n factor, so as number of equivalents can be written as n1v1. So just substituting the value of n1 from this equation, so we'll get m1 into n1 multiplied with v1 gives us m2 into v2 multiplied with v2. Okay, so in this case also we can get the same thing. Okay, so we also know from a second formula that number of equivalents of any substance is equal to given mass of that substance, in this case A divided by equivalent weight of the substance. So in this case number of equivalents of A, let's say we can write it in terms of W upon EA and we can equate it to number of equivalents of B, which would again be WB upon EB. But we can also write number of equivalents of B, as we know that from a B rate we know the normality and the volume of B which we are using in the titration. So as a result we can write it NB into VB also. So this part is known. From here we can know the weight of A which is actually getting reacted with the titrant. Okay, so suppose if our sample A also contains impurity, means it contains sample A plus some impurities, then the milli equivalent of A which is present in the sample should be equal to milli equivalents of B. So given mass of A can be calculated via this with the help of EA and N into V divided by 1000, because we are taking this number of equivalents in milli equivalents. So how are we actually defining it? So it has been defined as, so we have that, suppose we have the equivalents of A divided by volume of B in liter. This would be the normality ideally, but suppose we have B in milliliter. So what will happen is we have to multiply this with 1000, and this will and this term will be milli equivalents. Okay, so we can just write that normality, or rather milli equivalents of B would be normality into volume of solution B in liter, just multiplying this with the right hand side and dividing this with this factor on the right hand side. Okay, so this would give the resultant. Next, let us talk about primary standard and secondary standard. So primary standard is considered to be 100% pure substance, or a substance which with high purity and which is stable in nature and has high equivalent weight, and whose specific concentration or in terms of molarity we know already. Some of the examples of primary standard are Na2C2O4, K2Cr2O7 and sodium bicarbonate. And the example, what is the secondary standard? Secondary standard is nothing but the standard in which we know the approximate concentration of solution, and this has to be further standardized with the help of primary standard to know the concentration or validate the concentration of this particular secondary standard. So in herein first we titrate the primary standard with the secondary standard, hence the milli equivalents of secondary standard in the mixture we are dropping primary standard from the burette and secondary standard is in the mixture. Okay, so primary equivalent of secondary standard should be equal to milli equivalents of primary standard which are dropping off from the burette, because its concentration is the concentration of primary standard we know, hence the concentration of secondary standard can be known from this formula. Okay, so this is done to confirm the purity of secondary standard with the help of primary standard. Okay, so examples of secondary standard can be KMnO4 and Na2S2O3. So next is, if two reactants present in the mixture, that is A and B, are reacted with a third substance, then what will happen? So in case of complete reaction, what will happen is that milli equivalents of A plus milli equivalents of B would be taken together and should be equated to milli equivalents of C, so as to get, or rather so as to get the anything which is desired from this equation, as in this would be written as NaVa plus NbVb should be equal to NCVc. So this can be used to know any of the concentration desired. Suppose we want to know the concentration of A when the concentration of B is known, or vice versa. We can know from this equation. Okay. So with this we come to the end of this lecture. In the next lecture we will be seeing iodometric titration and iodometric titration. Till then, good luck and goodbye.